Now, this is an excellent place to investigate electricity. Just look, it's everywhere. But what about magnetism? I can't see any of that around. I'm going to need help. And luckily for me, somewhere here is Dr. Mike Diprose, who's a real expert. Mike, hi, found you. So, what is the link between electricity and magnetism?
Well, I'm just about to show you.
I don't think I like this investigation anymore. We're awfully high up.
Mike, what happened then?
We've just dropped 42 metres in just over 2 seconds. The reason we didn't crash into the ground is because of electricity and magnetism. Come on, follow me, I'll show you. Now, we already know that if we pass an electric current down a wire, it generates a magnetic field, and in fact, the reverse is true as well, and I can show you this. If you'd like to hold the wire, well, I get the magnet, that's right. Now, if you move that wire past the magnet, now you should see a needle moving, can you?
Yes.
Yeah?
And that's current being generated in the wire.
That's right, yeah. Now, it also works if you move the magnet past the wire.
Right.
So it doesn't matter which is moving, one or the other, provided it's moving, you get electricity.
And that's basically what's happening with the ride. As this compass shows, the carriage has lots of very strong bar magnets. And instead of a wire, the ride has 7-metre-high aluminium fins. Every time the magnets in the carriage pass the fins, an electric current is generated.
It's all very interesting, but what use is it?
Well, what happens when you have an electric current?
You get a magnetic field.
Exactly, and that's how the ride works. Now, I can show you with this model. This red box represents the carriage, and on the side, 2 strong permanent magnets. Now, we take it up to the top. When I let go, crashes straight down. Now, these pieces of metal there represent the aluminium fins.
Now, these are aluminium just like on the ride.
That's right, yeah.
But they're not magnetic.
No, but it does conduct electricity, and that's the important thing.
Right.
So if we put those now on the side, now when we lift up the carriage and you let go, it slows down.
Fantastic.
The magnets on the side induce an electric current in the aluminium plate.
And that, in turn, generates a magnetic field back to the magnet.
That's right. And the two together slow the carriage down as it comes down.
Well, that's all very clever, and it obviously works. But Stella's been using electricity to make magnets, so maybe they would work here as well.
But why not use electromagnets? They're seriously strong.
Well, imagine what would happen. You're winched up on the ride to the top, you're halfway down, and there's a power cut. What happens?
No power, no brakes.
Exactly. No Howie.
No way. Do you know what? I'm getting a serious bit of respect for magnets.